Welcome back to Ubuntu Mastery, Lesson 8, where we tackle two distinctly Ubuntu topics in one sitting. First up is DNS resolution, which on Ubuntu means systemd resolve by default, a major delta from Debian's resolveconf, and the source of countless "why isn't my DNS change taking effect?" headaches. Then we pivot to LXD, Canonical System Container Hypervisor, not Docker, that's Lesson 21. By the end, you'll be fluent in resolve style, unbound caching, bind authoritative zones, and the system versus app container decision. So let's start with the headline gotcha. On Ubuntu, etc resolve.conf is a symlink to a stub file that system resolve manages. Edit it directly and your changes vanish on the next reboot or network event. The right move is resolve status to see what's actually resolving, then drop your name servers into system.da resolved.conf. Cloudflare and Google here as primaries, Quad9 as fallback. While you're in there, flip on DNS over TLS, opportunistic to encrypt queries, and DNS-C allow downgrade for validation that won't break on misconfigured zones. Restart the service, and from then on, resolve kill query is your dig replacement for the local stack. Now, when resolution misbehaves, don't guess. Work the diagnostic pyramid. Start with dig plus trace, which bypasses every cache and walks the chain yourself. Root name servers, then the .com TLD, then the authoritative server for the zone. That's ground truth. From there, query each resolver explicitly. Cloudflare at 1.1.1.1, Google at 8.8.8.8, and your local stub at 127.0.0.53. If the upstream answers correctly but 127.0.0.53 disagrees, your local cache is stale, and resolve CKL flush caches fixes it. And one Ubuntu note, dig ships in B9 DNS utils now, not DNS utils. Install it explicitly because ens lookup is deprecated. Once you've mastered diagnostics, the next step on a real server is replacing system resolved with something built for load. Unbound is a validating, recursive, caching resolver. DNSSEC on by default, and we'll forward over DOT to Cloudflare, so upstream queries are encrypted. First gotcha. System resolved already squats on port 53, so flip DNS stub listener to no and restart it before unbound can bind. Then drop a config under cherry unbound.conf delmarine. Generous cache sizes, prefetch to keep hot records warm, QQ name minimization for privacy, validate with unbound check conf, and watch your hit rate climb with unbound control stats. Recursive caching is one half of the picture. The other half is being authoritative, actually owning the answers for a zone. That's where bin9 comes in. Install bind9 and bin9 utils, declare the zone in named.conf.local as type master, point it at a zone file, and restrict transfers to your secondary's IP. The zone file itself is classic, SOA with a serial you must increment on every edit. Burn that into muscle memory. Then NS, MX, a C name for www, and a wildcard SPF. Before reloading, always run namecheck.conf and namecheck.zone. A typo here takes your whole domain offline. Now we pivot from DNS into containers. Specifically LXD, Canonical's take on system containers. Think of it as LXC with a proper REST API and a curated image server bolted on. The mental model matters. These aren't Docker containers running a single process. They boot a full init system with Ubuntu, Debian, or Alpine userland inside, so they behave like lightweight VMs. On 2404 and later, snap is the only install path. Get it, add yourself to the LXD group, then run LXD init and walk the wizard. Defaults are fine. Those SFs beat steer once you care about snapshots. After that, LXC launch pulls the image and you're in. Daily driving is just list, exec, file push and pull, clean, predictable, and refreshingly undocker-like. Before we go deeper, let's settle the question everyone asks. How is this different from Docker? Same kernel, primitive, completely different philosophy. LXD gives you a persistent machine, full init, multiple services, state that survives reboots, so it slots in where you'd otherwise spin up a KVM or VirtualBox VM. Docker gives you one process, ephemeral, rebuilt from an image every time, which is exactly what you want for microservices and CI pipelines. They're not competitors. Most serious shops run both. LXD for dev and multi-tenant workloads, Docker for production app deploys. We'll cover Docker properly in Lesson 21. With LXD running, 3 features turn it from a VM replacement into a proper lab cluster. Profiles are reusable templates. Define CPU, memory, and mounts once. Then chain them at launch with multiple profile flags. Edit the profile later, and every container inherits the change. Snapshots capture state in milliseconds, so before any risky apt full upgrade or schema change, you snap, test, and restore if it breaks. Projects give you namespace isolation on a single host. Staging containers can't see default ones, which is how you keep dev VMs and prod VMs from colliding. And when you need to move a container between hosts, LXC export and import give you a portable tarball. No shared storage required. So when do you actually pick LXD over Docker or a full VM? The rule of thumb, Docker for stateless, ephemeral, single-process workloads, microservices and CI runners. LXD for anything that looks like a long-lived machine, dev environments, multi-tenant hosting, distro testing, legacy pinning. Reach for a real KVM or QEMU VM only when you need hardware-level isolation with a separate kernel, like a database under strict compliance, because LXD shares the host kernel, and that's the one boundary it can't give you. Everything else, LXD covers 80% of VM use cases at 1/10 of the overhead. Now let's talk about the 5 things that will absolutely bite you. Number 1 is the classic. You edit, chachu itseri, resolve.conf, it works. You reboot, it's gone, because that file is a symlink to system resolve's generated output. Edit, champion, etc. system or resolved.conf instead. Number 2, the bind SOA serial. Forget to bump it and your secondaries happily serve stale data. 3, unbound and system resolved both want port 53, so set DNS stub listener no first. 4, UFW blocks LXD's forward chain by default, hence allow routed. And 5, snapshots silently fill var snap LXD until containers refuse to start. Audit them or move to ZFS with compression. So let's recap what you actually own now. 6 concrete skills. You're fluent in system resolved. You troubleshoot DNS top-down with dig and trace. You run unbound as a validating resolver forwarding over DOT to Cloudflare. You serve authoritative zones with bind, bumping that SOA serial every single time. You launch LXD system containers with profiles and snapshots, and you know exactly when to reach for LXD versus Docker. Full OS and persistent versus single process and ephemeral. Next lesson, we go deep on storage and LVM, snapshots, online resize, and the logical volume patterns that actually hold up in production. That's lesson 8 in the bag. System resolved, unbound plus bind, LXD containers, and the LXD versus Docker call, all yours. Next up, lesson 9 takes us into storage and LVM proper. Physical volumes, volume groups, logical volumes, snapshots for backup without downtime, online resize with LVX10 and resize 2Fs, and thin provisioning with RAID on top. Grab a coffee, then run next lesson. Start. See you in 9.